Charles. My name's Randy Brooks. I am Valerie's dad, and I'm an architect. And I'm going to tell you a few things that you need to know if that's something that you might want to do as a career. An architect is a designer, and just about everything that we purchase or buy or almost anything that you look around, someone had to design that. And they had to think about how big it should be for it to be purposeful and useful. And we do the same things as architects. We try to determine what our client needs as far as a space to perform the work that they do. Maybe it's different functions. That maybe it's a doctor and they need exam rooms, or they need an emergency room, or whatever they might need. We need houses. We need houses to live in. So we have different rooms for different things, and we have to think about how big those rooms have to be. That involves measurement, and everything that we measure, that's a math project, really. When we do building plans, how do we get these plans of great big buildings to where somebody can actually know how they're supposed to build them? Well, we give them a dimension, what's called a dimension. And a dimension is if this is a small building, we'll put a dimension on that of how long we want that building to be, and how wide and how tall. Let's say we want that building to be 400 feet long, and we want it to be 200 feet wide. Okay, how am I going to show somebody how to build that building if it's actually 400 feet long and 200 feet wide? I have to reduce the size of what that shape needs to be with dimensions and with a scale. Let me show you what a scale is. This is an architectural scale, and I want to show you right here. This is 1 inch. This is just like if you got a measuring stick out, this would be 12 inches from here to here. Okay, a lot of our plans are at 1/8 scale. And you see those fine little, those are inches. So from here to here represents 1 foot. So we've taken that big scale, this 1 foot, all of that, and made it into one little space like that from 0 to 1. That's how we can do a plan and show it accurately, and how we can convey the designer's intent of how they can build that. Okay, so we will start off with a plan, and a plan is something that, if you think about a house or a building, and this
or a school, you do lots of schools,
and this giant saw comes and just saws off the entire, all around the building, and you just lift up the roof and you look down. This is like different rooms in your school. This is actually a school that just has been built in Moreland, Oklahoma. This is a classroom, and that's showing a classroom that is 25 feet wide right there. And here's another. These are dimensions. That's what I was just telling you about, these dimensions. That's how the contractor knows how to lay out this building correctly. If he didn't have this, he wouldn't have any way to know if something was square. And when I talk about something being square, we want our floor to be level. We want our walls to be straight.
Can you tell them, what does level mean?
Level means that it's flat.
Okay,
And
so
flat. It doesn't move one way or the other. Miss Brooks, show them outside how sloped that backyard is. That is not level, is it?
No.
And it
has highs and lows.
And
that's why there's some water collecting.
If you don't have everything to drain right, if it's flat outside, you don't want it to be super flat outside, because then the rain won't drain away from your building.
Well, even that fence right here that I'm zoomed up on, you can tell that those are not straight. So, yeah. that would not be flat.
So we have what's called an engineer, and engineers will help us with our design. There's a structural engineer that will take math, and he will determine how strong a beam or column needs to be to hold up our buildings, because these walls have structure in them that helps hold it up, and we space that structure at certain intervals, like maybe every 2 feet we'll have a wall stud, and sometimes buildings have beams that go across every 5 feet or every 20 feet, and that's what helps hold up the roof, and it makes it rigid. So a structural engineer uses math to calculate what the strength needs to be for these columns and beams. Then we have mechanical engineers that they use math to determine how much air goes in the vents. Like a vent right up there, that has a duct, what they call a duct, and somebody had to figure out how big that needed to be so that the right amount of air would get to the room that you want it to. Okay? Electrical, they use calculations because we have lots of plugs in our house, don't we? Lots of things we plug in. Well, every time we plug something in, that uses a certain amount of electricity, and we have to measure how many of those outlets can be on one circuit, because if we didn't, we could have a fire. So mathematics is used for electronics also. Let's see. We talked a little bit about outside. A civil engineer, they look at the land around your building and how that land works with the parking lot, because cars have to have certain, they can go on different levels, but if it gets too steep, they can't go up the driveway, can they? So they have to figure out how the water drains away from the building and drains where it's supposed to go into ponds and rivers and takes the water away. That's one of the things that civil engineers do. Okay, well, an architect will get a team of engineers and help, those team of engineers will help the architect design what is best for the owner or the client. And
So for the school or for the fire station or for whatever
company,
building
yes.
that people are building.
The client would be the people like your superintendent of schools and your board of education, those people that determine how they spend their money and what they want to build. So we use math to help us measure things. Everything that is designed by a designer. Everything that you look around and see outside has been designed. Someone had to put thought into that. I was just thinking about a tree. A tree needs water to grow. It needs light to grow. But it also has a DNA, because what makes up the cells of that tree tell that tree when to stop growing, don't they? Because if it didn't, what would happen? That tree would just keep getting bigger and bigger and bigger and never stop. Pretty soon there wouldn't be room for anything else, okay? So there's a design, and there's boundaries when we have designs. Let me show you something else. If this is our building, there's something called a property line. And when we buy property, or even if we just live on different property, that property is contained with boundaries. So when we bought this house, we bought this land that was on it, and that fence line that we saw, that is a boundary. That's a boundary. And we put up fences a lot of times right on that boundary. That's where our fence will be. Now, if you live in the city and you want to build your house, you can't build your house right there on that property line. The city has setbacks, and they're going to tell you you have to be 15 feet away. You have to be 25 feet away here before you can build your building. That means we could actually move this building, we could make this building this big, and we could come down to this line if we wanted to and make it that big, but we couldn't go beyond that because that's called a setback. And that's a legal term. Again, we're using numbers and dimensions and measurements. And just think about everything that you do. This computer screen, somebody had to think about that design of that, how big it would be.
And the buildings that you're seeing on the computer screen are buildings that they have done at where do you work at?
LWPB Architecture. And these are schools. This is a library on Northwest Oklahoma City.
That you got to help design?
Mm-hmm.
Yep. So some
see the angles?
Buildings.
I want to show you something else. I love cars.
And he also loves Dr. Pepper. He's not normally working in this study. He normally works at an office.
Okay, do you remember
that is why he has a card table.
Do you remember what I told you about scale? Because the people that made this whole car used a scale, and this scale says 1/18. Let's see. Yeah. I don't know if you can see that or not, but it has a scale on here. It says 1/18. And what that means, that's a fraction.
Mm-hmm.
So, let's see, I'll wipe this off.
Oh, there's wipes down there. You could. Oh, yeah, there's a mic cleaner one. Yeah.
Okay. Okay, scale is 1/18. That's a fraction. Okay? Mm-hmm. If they tried to make this car full size, I wouldn't be able to put it up on that shelf.
With the other
cars. I wouldn't be able to afford it either, by the way. But this car model was made in 1955.
Which is the year my dad was born.
A very good year indeed. Every curve and every angle of this car was designed. And they replicated every curve and every line
of the original.
Of this original design to 1/18 scale. That's why I can hold it right here in my hand.
She's a beaut.
It is a beaut. It's a Bel Air.
Yep.
Okay. And it's got a 1/18 scale engine in it too.
Oh, geez.
Okay. So, if we don't have the scale and we don't have the measurements, something could be totally messed up for us. Because what if we went to the store and we wanted to buy a lamp and that lamp was 15 feet tall? It wouldn't even fit in our room. What if we designed a room for a grand piano, one of them great big pianos, but we didn't make enough room in the aisle to get the piano into that room? You'd kind of be stuck, wouldn't you? Mm-hmm. Wouldn't work very well.
Wouldn't be able to get it in your house.
So, there's a designer behind what we make and what has been made. There is a design. And it takes
which includes math.
It includes math, but it includes thought, and it includes what the boundaries are and what you need to do. Your assignment, Ms. Brooks is going to give you your assignment, and you're going to have to use a tape measure,
ruler, whatever you can find at your house,
and measure your bedroom.
Or a room in your house. You can choose.
Any room in your house. How wide? How long?
Which is area. Length times width is your area.
Okay, let's say how long. Let's just make it a little bit longer so it looks how long.
Okay.
And then how tall is that room? The height. And the height.
which is volume.
We do a lot of our drawings on computer. I haven't did pencil drawings in many years. We're able to draw our plans up on computer very accurately, and it shows the builder or the contractor how to build it. These are floor plans right here. This is a floor plan. Let me show you an elevation. An elevation is actually just looking at that plan. If you were looking right straight in front of the building, what it would look like.
What you'd see if you're standing in front of it.
So,
that's cool.
That's the roof.
Mm-hmm.
This is windows, and that's a door. And this big room here is a band room for this high school. We have some angles in here. We have a big lobby that they come in, and this is glass. You can see through that. And this is very tall. This is 25 feet tall. This is probably about 18 feet tall. So the scale and we determine the volumes and what works for humans. We want it to be a place where humans would enjoy being in that space and that it would be functional. Art is also part of architecture and science too, so you better study your science. But creativity is a gift, and it's something that we can use in a way that's artistic, so that each building has it looks a little different.
Little different, right?
This one is different than different than a school,
right?
And the library is different than a school.
So things look different and have character.
And the site where you actually build that building or house makes a huge difference too. We want to make sure that we get good views out your windows. We don't want to have a window that looks into a trash bin or garbage. We want it to look out to something that is nice to look at. And so all of that thought goes into design. And it goes into the design of a chair, goes into the design of that chair, a lamp, whatever you pick up. Just remember, someone has thought about it and used dimensions to create something. And when you look outside,
which is measurement, right?
Yes, it's measurement. When you look outside, someone created everything that you see outside that we use for materials. One of the other things an architect does, we try to bring the materials that work best together so that that building can be put together without getting rain in it and snow, and we can keep it warm and cool. And that's enough for today.
Yes.
I've enjoyed talking to you.